Okay, so let's do practice quiz 8, number 1. It says, for the random variable that adds the values of two fair rolled six-sided dice, find the following. A, the probability distribution. B, the probability histogram. What breaks at those following numbers? So a probability distribution displays all the probabilities associated with all possible values of the random variable. Let's first look at the sample space. So S, so we could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then we could repeat these again and change the first guy to a 2. So we could have then a 2, 1. So again, 2, 1 means 2 on the first roll, 1 on the second roll, and 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then we just take all of these now, copy them and paste. It's the most efficient way to list them, so it'll be 3 then, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, then 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, and paste it again. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and then lastly 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So this is a sample space of rolling 2 dice. Now the random variable adds the sum of the 2 dice. So therefore 1, 1's the smallest we could get. So if you add those you get 2. So the smallest a random variable could be is 2. So x equals 2. So that'll be the probability of getting a 1, 1. Notice here, I should mention that up here, if you count the number of things in a sample space, you can check there's 36. So to get 1, 1, it's 1 out of 36. That's a probability. So the probability x is 2 then is 1 over 36. Probability x is 3. The probability of getting a 1, 2, I could then get probability 2, 1. And that's it then, so that'd be 2 out of 36. Next on probability x is 4. To get a 4, I could get a 1, 3, or I could get a 3, 1, or I could get a 2, 2. That's 3 out of 36. Notice it goes 1, 2, 3. So you probably predict the next one would be 4 out of 36. We can just double check that. So I could get a 1, 4, or 4, 1. Maybe speed up like this. 4, 1. Or I could get a 2, 3, or 3, 2. So it's 4. And you probably predict the next one should be 5 over 36. Let's just verify that. X equals 6. So I could get a 1 5, a 5 1. I could get a 2 4, 4 2, or I could get a 3 3. So that'll be 5 over 36. And probability, I'm going to keep going until I get to 12 because the biggest the two dice, the sum of the two dice could be is 12 if I get a 6 6. So probability x is 7, sorry. So probability of a 1 6 plus probability 6 1 plus probability 2 5 plus probability 5 2 plus 2, so it'll be 3 4 plus probability 4 3. So 1 2 3 4 5, yeah, so 6 of them. Then probability x is 8. You may predict this will be 7, but actually this actually goes down to 5. So I can't use 1 anymore because I can't get 8 if I have a 1, so it'll be 2 and 6 plus probability 6 and 2 plus probability 3 and 5 plus probability 5 and 3 plus probability 4 and 4. See, that's it then if you count them 1, 2, 3, 5 of them. So probability x is 9. So I could have a 3 and 6, or 6 and 3, or I could have 4 and 5, or 5 and 4. You can see that you can check that's it for this one. So 4, probability x is 10. Yeah, so I could have a 4 and a 6. I could have a 6 and 4. I could have a 5 and 5. And it's 3 over 36. 2 more to go. Probability x is 11. Probability, so it'd be 5 and 6 plus probability 6 and 5. That'll be it then, so it'll be 2. And the last one, probability x is 12. Oops, it's 12. That's getting 2 6s the only way. So it's 1 out of 36. Okay, so that completes part A. So let's look at part B. So part B right here says find a probability histogram with breaks at those numbers. So to graph a probability distribution, we find the height by taking the probability. It's right here. Height is the probability divided by the length of the bin. So we're going to have to create a table for this guy. So actually, let's bring this. I have a table on here. Let's bring it up. So I've started a table here. So actually, let's move this down to a new page. Okay, so the first bin. So our first bin is 1 to 2 right here. So it'll be. So insert here. Equation. So it'd be 1 less than or equal to x, which in turn is less than or equal to 2. Actually, sorry, I messed up in the first one here. The first one's strictly less than. Okay, so probability of the first bin, if you look, pretty much this is just when x is 2 then, because only values you can take between 1 and 2 is just 2, so it'd be 1 over 36 if you go back and look at the top up there. You can see probability x is 2 is 1 over 36. And the length of the bin, so just 2 minus 1, which is 1. So it means then the height is the probability divided by length, but the length's 1, so it's just going to be 1 over 36. Okay, then moving on to the next one. So let me just take this, repeat it down here. We just actually repeat it down here, and I'll just make adjustments to it. Okay, need to go here, say one more, or two more actually. Okay, so the second bin is, basically each bin is length 1, so the next one's from 2 to 3. Should be 2 here, 2, 3. Yeah, the bins are here. It's telling us the breaks, so we can find the bins from there. So it'll be then 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and lastly 11 to 12. Okay, so let's do one more here. So when x is between 2, strictly greater than 2 to 3, so looking up here, when x is 3 then it's 2 over 36. So I'll put it down here. 2 over 36. And the length of this bin, they're all 1 the lengths, looks like. Be 3 minus 2, which would be 1. So this would be just 2 over 36. Then moving to next one, that's going to be x between 3 and 4, it can equal 4, and strictly bigger than 3. So going up here, it's 3 over 36. So 3 over 36 goes here. So it'll be then 4 minus 3. This will be then 3 over 36. Oh, this is 1. So 3 over 36. Okay, and let's do, so x between 4 and 5, strictly bigger than 4, can equal 5. So going up here you can see when x is 5, we have 4 over 36. So 4 over 36 goes here. So it'll be 5 minus 4, which is 1. So this would be 4 over 36. Okay, so I'm going to stop it here because I'm out of time, so I'll continue this in the next video.